Again, so let's go ahead and get started on our arithmetic. So no delays here. Let's get right to it. So we're going to determine if something is arithmetic. That means does it increase with a common difference. We're just adding the same thing to a number. So 1, if we were to add 5 to each time, we'd have 6, 11, 16, so on. That would be arithmetic. So we just want to find to make sure that it has a common difference. All right. So I think this slide, I might be missing a note. But anyway, that's basically straightforward. We're going to look to see if it has a common difference. So we look here and we have plus 4, plus 4, plus 4, plus 4. So yes, and the common difference denoted by a little d is equal to 4. Jump down to this one, we have a plus 2, plus 4. We automatically know it's not. This is actually geometric. Here we have a minus 2, minus 2, minus 2, minus 2. And yes, and d is equal to a negative 2. So we're going to take this information and try and write some kind of useful formula for this. So jumping into this, here is something that looks like an arithmetic. And again, we're drawing back into your Algebra 1 where you did y is equal to mx plus b. That formed a straight line. Your arithmetics will do the same thing. But we're not interested in the graphing aspects of these. We're interested in something that's going to be involved with your future math classes, particularly calculus, on how these work out. And you'll get involved in some series in that course. So what we want to do is write the first 5 terms. And we've kind of done this, and I don't need to do all of them. So when we do a sub 1, that's just 5 plus 3 times 1, which is 8. Okay, a sub 2, I'll just do the next one. 5 plus 3 times 2, that's 6 plus 5 is equal to 11. Well, we're adding 3 to both sides, and yes, your algebra teacher would call that slope, even though it's not written in the form that you're used to. And you know the next one is going to be 14, so on. Okay, a sub 3 is equal to 14, a sub 4 is equal to 17, so on. Well, we almost immediately know that this is not going to be arithmetic. And I could prove that by doing, say, a sub 1 and a sub 2, and we're going to have to do a sub 3. A sub 1 is just 2 times 1 minus 1, which is 2 to the 0, which is equal to 1. Then we put in a 2, 2 times 2 minus 1, which is 2. And then put in 3, 2 to the 3 minus 1, which is 2 to the 2, which is equal to 4. Well, that's a plus 1, and that's a plus 2, so on. So we know it's not arithmetic. This one, yeah, just looking at it, it looks arithmetic, and we can easily prove that. I put in a sub 1, I'll just do one of these to work them out. And that's 1 plus 1. So that's 2, 8, 9, 10, 11. A sub 2, you do the same thing, you're going to get 15. A sub 3, you're going to get 19. That's good enough. I'm adding 4 to both sides. And again, your algebra teacher would call that the rate. But it's something different in calculus, all right? Well, kind of something different. Moving on. So now here's where we start earning our paycheck in PreCal. The nth term of an arithmetic sequence. So we had the form of this. Now, not all schools teach this form, okay? In fact, a lot of textbooks you won't even see this written anywhere. You're going to see this. And this is the way I was taught, and this is the way I've always worked my sequences and arithmetic sequences in series, was this formula right here. So what we want to do is find the explicit formula, which is either this one or this one. Now, we're going to tend to work in this one because that is the way the other teachers do it here at the school. So I want to be consistent with them. So when we do this, we're going to, first of all, try and get it into this form, dn plus c. And we have 1, a sub 1. So if we do a sub 1, that's nothing more than 1, is equal to 3 times 1 plus c. So that's 1 is equal to 3 plus c, so c is equal to negative 2. Now we can plug it into this form to have an explicit formula. So we're going to knock this out as a sub n is equal to 3n minus 2. That is your explicit formula. I can certainly have done it over here. I could have done a sub n is equal to a sub 1 is 1 plus n minus 1 times 3. Okay? And I could have distributed that 3. I could have left it like that. That would have been an acceptable answer on a college course. Or you can distribute it to 3, combine like terms, and you would have got the exact same thing. Okay? So let's go on to another example. So here we have one where a is 100. That's a sub 1. So we're starting at 100. And our difference, our arithmetic difference, is negative 8. So to find c, there's an easy formula. It's basically a sub 1 minus d. And again, we're looking at this formula here. Let me write in blue here. A sub n is equal to dn plus c. D being your difference, a sub n is whatever term you're working with, and c is that constant at the end. So we're just finding the c. That's nothing more than 100 minus a negative 8. And that's what c is equal to. So c is equal to 108. So we're going to write our formula as a sub n is equal to negative 8n plus 108. That's our explicit formula. Okay, moving on. So we're going to write the first 5 terms of the sequence, and we're given a sub 1 and a d of 1/2. So what we want to do is write our explicit formula first. Let's find our c, and again, c is equal to a sub 1 minus d. So that's nothing more than 3 minus 1/2, which is equal to 2.5. Writing our explicit formula, a sub n is equal to 1/2 n plus 2. We used to teach this about 5 years ago in Algebra 1, and I doubt it's taught in, you'd have to come from a different school system. Maybe you came from outer state or something to recognize this. But this used to be Algebra 1, believe it or not. So now we're just going to plug in. Well, a sub 1 is equal to 1/2 times 1 plus 2.5 is equal to 3. All right, and a sub 2, I could do another one. 2 plus 2.5 is equal to 3.5. And a sub 3, of course, is going to be 4.0. All right, moving on. So here we have 2, we have a sub 8 and a sub 12. Well, let me show you something. A sequence, we have 26 plus something, well, not plus, but we have something, and we end at 42. Now, this is the 8th term, and this is the 12th term. We have a bunch of terms in between, 4 of them, and we want to know how to get there. Well, there's an easy way to find our d. Our d is basically this minus that, 42 minus 26. It's kind of almost like the slope formula, to tell you the truth. And then 12 minus 8. So what we have here, when you put this all in, you're going to get 4. All right. Now, with that, we can absolutely find our c if we wanted to. But it was just asking to find our delta. All right. So we can find our c by doing something like this. We could take a sub 8. So we know that a sub 8 is 26 is equal to 4 times the 8th term, the 8, plus c. That's one way to do it. Okay. We don't have an a sub 1. Remember, your c is equal to a sub 1 minus d. All right? We don't have the a sub 1, so we're looking for c in a different way. So that's just 26 is equal to 32 plus c. So c is equal to negative 6. So a sub n is equal to 4n minus 6. That's my explicit. I certainly could have used the different formula. I certainly could have done 26 is equal to a sub 1 plus 8 minus 1 times 4. We're off the chart. Alrighty. And worked it out that way and found out what a sub 1 is. You'll find that a sub 1 is equal to negative 2. Alrighty. Okay. But we're just looking for the explicit formula. That's all. You're going to have to pause and redo this. You need to put pencil to paper when you do these videos. You just can't be watching. Alrighty, so what do we have here? We're going to look for the explicit formula, and we're going to find the missing term. We're going to look for here. Okay, a sub 10. Yes, and don't go do this. This is what middle schoolers do, and this would be a middle school problem if we gave it to you. 5, 11. Well, I just added 6, so that's 17, and you count. Well, in college, you're going to have a sub 983. So that's not going to work out too well, okay? It's not going to work out. So don't do that. You want to practice your math here. And this is also on the SAT. What is the 57th term? You're going to see that on the SAT as well. Okay, so we just need to start knocking it out. Well, our D is, well, we're given A1 and A2, so we know D is equal to 6. That made it easy. Well, that makes finding C easy too, because that's nothing more than, again, A sub 1 minus D. So that's 5 minus 6, which is equal to negative 1. So our explicit is A sub n is equal to 6n minus 1. We're going to use that to find A sub 10. So A sub 10 is equal to 6 times 10 minus 1. So that's going to equal to 59. Actually, not too bad. These aren't too bad. You need to pause, practice it, pencil to paper, and then proceed on to the next example. Okay, I'm going to leave it there and do part 3 sums in the next video.